O mundo à nossa volta é repleto de sons. Do canto dos pássaros até o barulho das folhas caindo nas árvores, tudo isso é muito mais do que som ambiente. Todos esses sons são essenciais para a manutenção da vida na Terra como a gente conhece. Diversos estudos apontam o impacto dos barulhos criados pelas nossas cidades e pela nossa sociedade no geral na vida animal, impactando tanto os padrões migratórios quanto padrões reprodutivos de diversas espécies. Pensando nisso, eu vim falar com o Nicolas, estudante de PhD em Materiais Acústicos aqui na Universidade de Coimbra, para tentar entender um pouco mais de quais pesquisas e soluções estão sendo propostas para esse tema.
So for this problem, what I am studying and designing is what it's called a noise barrier. So a noise barrier, I think the term is very self-explanatory, is a structure that contains noise and doesn't let it escape to other places so that it doesn't become annoying. Typical noise barriers, I actually have like pictures of it, so then maybe you can include in the video later and I can show you to you right now. So you're probably seen when you're in a train or in a bus, you've probably seen this structure all around the highways and things like that. So this is a noise barrier. So, but as you can see, it is like very disruptive. It is like a horrible like concrete metal
That's
wall.
what I was going to say. Like,
Yes.
I saw this when I was going to Milan, and like you leave the airport and you're entering the
Yes.
city, and it's just
This is all
horrible.
you see. This is all you see. You don't see trees, you don't see houses, you don't see anything. You only see like a big concrete wall next to you for hours and hours and hours and miles and miles and miles. That is horrible. So what am I proposing is something like this. So the last time that I was on holidays, I saw this and I was like, this is what I do. So you see in this picture that the ocean waves here look very much stronger than the ocean waves here. I have actually a video of it, like you can see it. So this is what is called a phononic crystal.
Okay.
So a phononic crystal is a metamaterial. So like more
What is a
context.
metamaterial?
What is a metamaterial? Yes, a metamaterial is like an engineered structure or geometry or something like that has properties that no typical material or no natural material can have. This is what I show you. This is a sonic crystal. So what it's doing, it's like this geometry of these like ocean walls and the spacing between each other. They are what they are keeping the like waves from entering the shore so that people can have a nice day at the beach. What I'm designing, it's a sonic crystal. So it's like a branch of a phononic crystal. Because a phononic crystal could be used in like solid and solid structures, fluid and solid structures, things like that. So a sonic crystal, it's like more specific to sound. So it's a solid structure in air. So what I am proposing is like something very similar to what you saw or what you will see in the video. Instead of having those like ocean walls, they will be like concrete cylinders of like maybe 12-15 centimeters in diameter, so like this big. And the spacing between them will be I mean, like right now we're working with like 17 centimeters. There's like a reason for that. I mean, like it is calculated. It's not like a random value. Those concrete cylinders will be like porous concrete. So the concrete will not be like this, like flat. So it will be like kind of chunky, like kind of like I think I have like a specimen like over there that I can show you like later. So the porous concrete actually absorbs sound because of its geometry, and the sonic crystal itself scatters sound. So when the sound tries to pass the barrier, in between the spaces, it would lose energy. So that's what it makes it like feel quieter when you're on like the other side of it. So that's what I'm designing. So this union of like material engineering with the porous concrete, with like the physics of acoustics, with the sonic crystal, making them work together and then adding more and more stuff to it so that you can have like a wide like range of frequencies that it works. So you can work on low frequencies and on high frequencies.
Technically, this should help, for example, for us to remove those ugly barriers.
Yes, it will be a replacement for these ugly barriers, like for this, like, and then you can have like you can see the outside. I mean, like people will not wake up and like the first thing that they see every single day is like a giant wall because they live next to a railway.
E é claro que eu queria conhecer o trabalho do Nicolas a fundo e como ele fazia os experimentos dele. De cara, ele me chamou para conhecer a sala anecoica. Repara na diferença do áudio aqui dentro.
So this is where we do our most of our acoustic testing. of like things that will actually be like on the ground, on like highways, railways, whatever. It's called the semi-anechoic chamber because these like sponges and these things absorb sound completely. So like when we put speakers and things like that in here, yeah, it's very soft. When we put speakers and things like that in here, I mean like these things avoid any sort of like echo and things like that. So like the sound can like escape, or like in real life it will escape freely. Here it will get like completely absorbed by this, by the material of the sponge and by the way it is like bent. So you have like no refractions or like anything like that. And it's semi-anechoic because the ground, it is still rigid. So you have the reflections from the ground. But that is useful because when you put things, like imagine if you put like something in the middle of like a stadium or something like that, it's like a very open air space, but you always have the ground. So you always need to consider the reflections and things like that for the ground. So for real life applications and testing and things like that, these sort of chambers is better than like the fully anechoic, where the ground is also like made of absorbing materials.
It's I feel like, you know, when you have like I don't know if it's called like muffins or something. Angelica is behind the camera. You know, like when you are in
your
winter.
Ears are blocked.
What?
Oh, earmuffs.
Exactly.
I didn't know that word. Yeah.
But you know, like if you are in your house, like just trying to cover your ears like this and speak like very loudly, that's the feeling that I have like
in here. Yeah, we spend a lot of time here, so I don't really feel it. I mean, like now that I'm speaking, like it's weird. I feel like the vibrations in my head.
Exactly.
Yes.
And like if I say something very loud, it doesn't get back. Like I cannot have the feedback of my voice.
It is really weird being here. But it is also a myth that you go crazy inside of these rooms.
Oh, those are the types of things
I mean like these are the types of room that you were supposedly go crazy in. I mean like that's a myth. I mean like I've worked here for like a lot of hours. Sometimes I get a little bit of a headache.
Sometimes I do try to cue other people.
But like it's not that you go insane.
E também fomos ter a experiência oposta de uma sala semi-anecoica. Aqui, tudo é pensado para refletir o máximo de som possível.
This is the building acoustics lab. So the way, I mean like the why, because this has to be like with so much echo and things like that, it's because you want the only thing to be absorbing sound what you put in this giant hole on the wall.
Oh.
So this is where we test like acoustic properties of materials, for like concrete, wood, glass, things like that you like need to use for construction.
A experiência de estar nesse quarto, que tenta refletir o máximo de som possível, para mim foi insuportável. É como se qualquer pequeno barulho que você fizesse voltasse para você 10 ou 100 vezes pior. Vocês perceberam no áudio como que isso funciona. Do outro lado dessa sala, atrás da parede que o Nicolas mostrou pra gente, tem o que a gente apelidou carinhosamente de The Bottom Room, porque é o quarto que recebe todas as emissões de sons desse quarto principal.
After we leave this also very strange experience, like coming just to different things, like if I got it right, basically what we were doing here, like on that first chamber that we were, we would play the sounds, and then the other one would receive it, and then you would be able to accurately measure if the material you guys were using would actually like good to absorb sound.
Yes, I mean like whether it's good or bad sometimes doesn't matter. Sometimes you just need to know how much.
Okay.
So because like when you're designing like a concert hall or like a building or like something like that, you want to know how much sound the concrete itself is absorbing. So whether so then you can use one of these like sponges or things like that that are like laying around in this entire room. Then you need to know, oh, the concrete is already absorbing this amount of sound, or the concrete is reflecting also this amount of sound. So you need to know that information. Whether it's good or bad depends really on the situation of what you're getting. I mean, like, not everything can absorb sound. Yes.
E antes de acabar a visita, tinha mais uma coisa que eu queria que o Nicolas mostrasse pra gente.
So this big lump of metal, this heavy, heavy lump of metal.
Quite heavy.
Yes. Yes.
It's like working out material.
It is actually, it is. So this big lump of metal is what we use to teach bachelor students about like vibrations and stuff. So what we use is we put the accelerometer, the thing that I told you about. It's magnetic, so we just like put it there. It's like very yes, it is a strong magnet. So then we hit it with a hammer. This is like a special type of hammer that's like weighted and like it has like circuits for like of course. So it is, like all of this is connected to a computer. So there's a cable going from here to the computer, and there's a cable going from like the hammer to the computer and like things like that. So then you hit it with a hammer, like literally like that, and or harder, or there are like other like you put weight on it or whatever. And then you test the vibrations of this thing in like different places of this like plaque of metal, of this like metal piece, and then you see the modes of vibration. So the modes of vibration, it's like the natural frequencies of this like thing. So have you ever heard about that like thing that happened in a bridge in the United States? I think it was that the wind was just like blowing so hard, and then the bridge started to like act like a swing, and then the bridge collapsed.
Yeah.
Yes, it's because the wind was making the bridge move at one of these vibration modes. So whether the vibration modes are like special frequencies, when this thing is like the weakest or the strongest, or like something weird happens to this thing in one of those like vibration, like one of those like frequencies. When you vibrate or when you shake this thing at one of those like frequencies. So then you use this to like see whether those frequencies happen or not, or like where they happen, because like everything has its like vibration modes.
That's what I was.
Yes, yes.
Like every material has
every single material has like yes. Like softer materials have like there's a special, but like every single like rigid material, you really need to consider like it's like modes of vibration. So when you're building a bridge, when you're building like a building or things like that, because like imagine that you have an earthquake at the frequency where the building has its mode of vibration, then the building will fall down.
Oi pessoal, bom, tô gravando isso daqui depois do vídeo finalizado, na verdade para fazer a finalização do vídeo. Peço desculpas, a gente ficou 6 horas gravando para conseguir gravar tudo que a gente precisava. Sei que não ficou perfeito, mas foi o nosso primeiro vídeo. E a gente acabou esquecendo de gravar um tchau para todo mundo pra gente poder finalizar o vídeo. Mas, bom, muito obrigado a todo mundo que assistiu até aqui. Se vocês quiserem saber mais da pesquisa do Nicolas, dá um pulo no nosso TikTok, que tem vídeos de conteúdo da pesquisa dele que não estão no nosso vídeo principal aqui. Se você quiser acompanhar tudo que a gente está fazendo ao vivo, dá um pulo no nosso Instagram, e semana que vem tem mais vídeo viajando para outros lugares, conhecendo novas pesquisas e novos projetos pelo mundo todo. Então, muito obrigado a todo mundo que ficou até aqui e vejo vocês semana que vem.